So this is G. In G, we're asked to calculate the length of PR. So this is how I would start out. I would start out by saying that PR is equal to PQ plus QR. PQ I would call X, and PR I would call Y. All right, so points to note. You need to note that these are two right angle triangles which are back to back. These are two right angle triangles which are back to back. And for both right angle triangles, so if this angle here is 90, it means that this angle here is also 90. So there's a right angle triangle over here to the right, and there's a right angle triangle over here to the left. Now, for both right angle triangles, I know the length of two sides. And if I know the length of two sides of a right angle triangle, and I wish to find the length of the third side, I must use Pythagoras Theorem. So I would say Pythagoras Theorem says that C squared is equal to A squared plus B squared. In the Pythagoras Theorem formula, C is the hypotenuse and A and B are the other two sides. In the triangle to the right, the hypotenuse is 13, so 13 squared, and the other two sides are Y squared plus 12 squared. 169, that's 13 squared, would be equal to Y squared plus 144. Positive 144 goes over and become negative. And so Y squared would be equal to, that looks like 25. The opposite of square is square root. So Y would be equal to the square root of 25. So Y, which is QR, would be equal to 5 meters. All right, let's find now the length X. Again, X is part of the triangle on the left. And the triangle on the left is a right angle triangle. That's this triangle here on the left. I know the length of two sides. One side is 12.5, the other side is 12. Now, if I know the length of two sides of a right angle triangle, and I wish to find the length of the third side, I must use Pythagoras Theorem. So Pythagoras Theorem says C squared is equal to A squared plus B squared. This is the Pythagoras Theorem formula. In the Pythagoras Theorem formula, C is the hypotenuse and A and B are the other two sides. In the triangle to the left, the hypotenuse is 12.5. So this is 12.5 is equal to, the other two sides are 12 squared, so it's 12.5 squared is equal to 12 squared plus X squared. 12.5 squared is 156.25. And this is equal to 144 plus X squared. Positive 144 goes over and become negative. And this is equal to X squared. So X squared is equal to 12.25. The opposite of square is square root. So X would be equal to the square root of 12.25. So X, which is PQ, is equal to 3.5 meters. So therefore, ladies and gentlemen, the length of PR is the length of PQ, which is 3.5, plus the length of QR, which is 5. PR is 8.5 meters. The length of PR is 8.5 meters. So as I said to you earlier, the questions we're doing may require you to apply Pythagoras theorem twice, one, and then after that, you're either going to have to add or subtract. So let's have a quick look at H. In H, this says the triangle below, in the triangle below, LM is 6 centimeters. So LM is 6 centimeters. MN is 5 centimeters. We're to calculate the length of PO. So we want to find this length here. PO. If you want, we could call it what? Z. No, there's only one way we're going to find that length. We're going to have to first find this entire length, the length from O to M. We're going to have to first find this entire length, the length from O to M, which I'm going to call X. Then we need to find the length from M to P, which I'm going to call Y. And then Z would be equal to X minus Y. Z would be equal to X minus Y. Now, X is the length MO. Now, MO is a part of the right angle triangle to the right. MO is a part of the right angle triangle to the right. Now, if I know two sides of a right angle triangle and I wish to find the length of the third side, I must use Pythagoras Theorem, which says C square is equal to A square plus B square. Now, in the Pythagoras Theorem formula, C is the hypotenuse and A and B are the other two sides. Now, the hypotenuse is the side in front of the right angle triangle. So in this question, the hypotenuse is 13. So 13 square is equal to A and B are the other two sides. The other two sides are 5 square plus X square. So X is the length from M to O. 169 is equal to 25 plus X square. 169 minus 25 is equal to X square. So positive 25 goes over and become negative. So X square would be equal to 144. The opposite of square is square root. So X would be equal to the square root of 144. So X, which is MO, is equal to 12 centimeters. So the length from M to O is 12 centimeters. Next, I need to get the length MP, which is Y. Now, MP is part of the triangle on the left. Now, the triangle to the left is also a right angle triangle, and I know the length of two sides. The longest side, which is the hypotenuse is in front of the right angle, that is 10 centimeters. And the other two sides are Y and 6 centimeters. Pythagoras theorem formula says C square is equal to A square plus B square. In the Pythagoras theorem formula, C is the hypotenuse and A and B are the other two sides. The hypotenuse is 10, so this is 10 square is equal to the other two sides are 6 square plus Y square. 10 square is 100 6 squared is 36 plus y squared. Positive 36 goes over and become negative, so it's 100 minus 36 is equal to y squared. Y squared would be equal to 64. The opposite of square is square root. So y is the square root of 144. So y, which is MP, is equal to, all right, I made an error. I'm fixing it now. So it's the square root of 64. So y, which is MP, is equal to 8 centimeters. Now, from M to O is 12. From M to P is 8. Therefore, PO, which is what we're asked to find, is equal to MO minus minus MP, which is equal to 12 minus 8. PO is 4 centimeters. So the length from M to O is 12. The length from M to P is 8. Therefore, the length of PO is 8 centimeters. We must get familiarized with questions like this because when we get to trigonometry, it will involve the use of this skill. All right. The last question under Pythagoras Theorem. All right. So it says in the diagram below, triangle ABC. So you have triangle ABC and triangle ABD are right angle triangles. So this is the idea here. The idea here is that you have two triangles, two right angle triangles. There's a smaller right angle triangle, which is ABD. I think everybody should be able to see that. And there's a larger right angle triangle. And this is ACD. All right. Now, the only issue is that the smaller right angle triangle is inside of the larger right angle triangle. So if I did this, this would be the scenario that we have. The triangle ABD is inside of the triangle ABC and ACD, and the two triangles share a common side, and that is the side AD, which is 15 meters. So we're told that what AD is 15 meters, BD is 17 meters, and CD is 39 meters. We're to calculate the length of AC. So this is done in parts. We're first asked to calculate the length AC. So I'm erasing this. Now, we need to calculate the length AC. So AC corresponds to the big triangle. If you sort of get this out of your mind, that middle piece, we can easily see that AC, I'm going to call that length X. That's AC. Now, so we have a big right angle triangle. The hypotenuse is 39. And the other two sides are 15 and X. So if I know two sides of a right angle triangle and I wish to find the length of the third side, I will use Pythagoras Theorem, which is C squared is equal to A squared plus B squared. In the Pythagoras Theorem formula, C is the hypotenuse and A and B are the other two sides. So this is 39 squared is equal to X squared plus 15 squared. 39 squared, using my calculator, is 1,521. This is x squared. 15 squared is 225. Positive 225 goes over and become negative. And so x squared would be equal to 1,296. The opposite of square is square root. All right. So it's the square root of 1,296. And this says x, therefore x, which is AC, is equal to 36 meters. So the first thing we're asked to do is calculate AC. And for AC, we got 38 meters. I'm going to erase whatever we did here. All right. That was just to help us to understand. Next, we're asked to calculate the length of BC. Now, the only way possible we're going to get BC is that we have to first calculate AB. And AB I'm going to call Y. And BC I'm going to call Z. Now, if I know X and I know Y, to find Z, I would simply take away Y from X. So let us find Y. Y is part of this little right angle triangle here. And of that little right angle triangle, I know the length of two sides. I know that the hypotenuse, which is in front of the right angle, is 15 meters. And the other two sides are it's 17 meters. And the other two sides are Y and 15 meters. So C squared is equal to A squared plus B squared. The hypotenuse is 17, the longest side, and it's in front of the right angle. 17 squared is equal to Y squared plus 15 squared. This is 289, I think. This is Y squared plus 225. Positive 225 goes over and become negative. And so Y squared is equal to, what does this look like? 64. The opposite of square is square root. So Y is equal to the square root of 64. Y, which is AB, is equal to 8 meters. So finally, BC is equal to AC minus AB, which is X minus Y. Which is 36 minus 8. The length of BC is 28 meters. The length of BC is 28 meters. And that is the end of this part of it. There's a little tiny piece of Pythagoras Theorem leave. We have to look at the a special aspect of the isosceles triangle, and that is what we're going to look at next.